Hello everyone, I want to show you guys a new poleaxe that I just finished. Okay, so this is the one that I just finished. This is the one I did last week. There's a couple of things that I learned on this one that I kind of brought over into this one as an improvement. So this one's got some cool lightning cuts, right? It's got these cuts here so I can kind of look at people through the two holes. So that's kind of fun. We're going to talk about that in a minute. So both of these are based on a historical poleaxe that's found in the Wallace collection, number A925, A925, and I'm going to include a picture of the original. So something that stands out about the original, I think that's kind of like the defining characteristic, and I do consider number A925 to be the queen of poleaxes, right? I think that's like the best poleaxe that was ever made. Now, mind you, these are very specialized weapons. So, if you're doing, singles combat or tournaments, that would be different than, let's say, something that you would want to take into a battlefield. If you're going to be opposing horses and stuff like that. So I've designed this to be a tournament poleaxe for singles combat. It's designed to be very lightweight. It's basically a spear. Okay, it's a spear. It's really light. It weighs 4 pounds, 14 ounces. So it's lighter than this one. This one came in at 5 pounds, 5 ounces. All right, so I actually was able to, even though this one's longer, I was able to lighten it up. So this one is 72 inches long, right? So this one is like a 6 foot long. This one was 68 inches, right? So 68. So I was able to go up to 72 inches and come out with a lighter polearm. Okay. So one of the things that stands out about this polearm that's in the Wallace collection, number A925, is that the langets, it's got langets that run the whole shaft, okay, and it is fully enclosed up here. So I consider this a primary hitting area over here. So with this one over here, now I didn't fully enclose it. And the reason for that is because I just didn't think it was necessary. I mean, these langets come all the way to the edge. So when you hit, you're hitting with the steel over here. And there's 1/8 of steel on each side. All right, so that's a total of 1/4 inch of steel over here, that you're hitting with, okay, 1/4 inch. So the other thing I was able to do is this is actually about 2 inches longer. So I was able to, with this one, I went a little bit shorter with those langets from here up to here. So with this one, I was able to get an actual, like almost an extra 2 inches of length. Okay, and still come in lighter. So the way this works is this is, in order to get that lightness, this is tapered both this way and this way, right? So it gets thicker over here, and it comes up and it gets thinner as you get to the top. And the same thing here, it gets thicker out here, it comes up, and it gets thinner at the top. Okay, so and again, we don't need to have a whole lot of wood in here, right? Or a whole lot of metal, because there's 1/8 of an inch on each side, 1/4 inch. So we can afford for this area here to be thin, and we still got a lot of strength. Now, once you get past this point over here, these langets over here, they get thinner, right? It's maybe like a 1/16, okay? So they get a lot thinner down here. And with this one, I went all the way down, and I basically married it to the end cap. Now, again, the end cap also, at this point over here, it is 1/8 of an inch thickness. So this is a very solid hitting area. And then it tapers into these langets here, which are like a 1/16. So by going light over here on the langets, I'm able to reduce the weight, but I still have a very, very solid shaft over here, okay? And the shaft is only 3/4 of an inch thick. Okay, so if I didn't have these langets here on the side, this shaft would have to be at least 1 inch thick, probably 1.25 inches at the minimum, right? In order to have that strength. So I was able to put these steel reinforcements on the side here, and that's what allowed me to go thinner on the shaft. Now, most historical poleaxes, right, they don't have these langets that go all the way to the bottom, right? The way they have a stronger shaft is just by going thicker. Like they'll be an inch, inch and a quarter, inch and a half, maybe even 2 inches, so they use more wood. The issue, so here's the thing, a lot of it comes down to what resources are available to us, okay? They used ash wood, mostly ash wood. They also used other woods, but ash wood is really not available to us here in the U.S. because of this beetle that's been eating all the ash trees. So it's either not available or extremely expensive. The oak is also a historical wood, but it's it's historical wood, but it is more available. So basically, when I go to Lowe's, because that's where I got this oak wood from, right? They sell it in inch and a half by 3/4 of an inch. So that's really cheap, right? I was able to get like an 8-foot shaft for $20. Okay, so if I try to special order oak that was a lot thicker, now we're getting into $100 or something. Basically the wood starts getting really, really expensive. So as it turns out, just the resources available, it is cheaper for me to put metal in here than it is to put more oak wood in here. Okay, so the availability of resources and the price is one of the things that drives the construction of these weapons, and always has. Okay, so we've got, so starting from the top, we got a top spike here. I went with an actual spike this time as opposed to the curved blade that I went with last time, just because when I was working this on the anvil, it just took an interesting curve, and I just kind of ran with it. Okay. Now also what I did here is with this one had more axe over here. So this one kind of more resembled this poleaxe that I fight with, which is more has more axe. And one of the things that you'll find with these axe heads is that obviously the axe side tends to be heavier, right? So this is not balanced on its y-axis as opposed to this. Okay, this has equal weight on both sides, so this is balanced on its y-axis. It doesn't matter how you spin this. I actually balanced this on my finger before I mounted it. This is perfectly balanced on its y-axis, so it wants to, when you swing this, it doesn't really want to roll over. It just wants to go wherever you take it, because of that balance. So that's one of the things that I wanted to bring into this, right? So this is balanced on its y-axis. It's got these holes here that I fire cut while I was forging this. And the nice thing about these fire holes, they these lightning cuts, they reduce the weight, and it also gives me something to look at people through. So I can look at people like this. So now the way I made these fire holes, what I did is I took this hammer here. I basically put it here on the corner, and then I hit it with another hammer back here, and under the extreme heat, it basically split. It split this. Now initially what happened was the split wasn't anywhere as big as it was here. Okay, so one of the things I noticed from the first poleaxe project that I did is that the heat consumes a lot of the iron. Okay, so as the iron goes in and out of the fire, every time it comes out and it's red hot, it's basically, it starts flaking, right? The scale, it appears like flakes, and that's basically like accelerated rust. Okay, it mixes with the air, and you lose a lot of steel. So I actually worked that into this design because what I did is I cut these holes really thin, right? I punched these holes really thin over here, and then I let the fire actually do the work for me. So the next time it went in to do something else, right? Like let's say I wanted to shape, the corners over here, right? When it came out, every time it went out, this hole had expanded a little bit, right? So the fire formed these holes for me, and I did work it a little bit to shape it a little bit, but yeah, when I forged it, these holes were not that big. They were the oxidation actually created these holes after I made small, tiny little slits. Now, speaking of oxidation, when you're making this, the question comes up: hey, if this is such an awesome design, why aren't all poleaxes, why don't all poleaxes, right? All the historical poleaxes that we see in museums, why don't they have these langets going all the way down the edge here? So one of the things, in order to like make this right, I had to use really thin metal. I have to forge really thin metal, and it's hard to get it perfect, okay? Because you start out with a certain thickness, and then the fire consumes some of it, so it's hard to tell what you're going to end up with. So there was a lot of trial and error, several attempts to end up with a metal that after I forged it, right, after I hammered it, gave me the thickness that I wanted to, right? And the other thing is, before I attached this to the shaft, this steel looked like a ribbon, okay, because it's so thin, so it's really hard to work with it. The truth is, I put more time and effort into, or almost more time and effort into creating this reinforcing langet and getting it on this shaft than I did creating the heads over here, right? So this was more effort than that, just because I'm working with a really thin metal that wants to burn up in the fire and curl up on me when I'm trying to hammer, and it's never going to come out perfectly straight. So the way I did with this, I had to I basically riveted it in, and then I'm working with two sides at a time, so I'm putting in one rivet at a time here, and trying to straighten this out as I'm going down the shaft, right? Because I got it here, and now I got this ribbon that's over this way, and then the ribbon on the other side is going the other way. So this is extremely hard to work with, metal that's this thin and this long that wants to curl up on you. So that's the reason why I think that most poleaxes do not use this design. They just prefer to go with the thicker wood because it's just less work, cheaper. But in my case, since I didn't have good, thick historical wood available to me, right, it was actually cheaper to go, with the metal and do the extra work than to get a thicker shaft. It just wasn't available to me. I'd have to, go either special order it or go running around to different lumber yards trying to find a thicker wood. Okay, so that's interesting how that worked out. So I this up to the end cap over here. Again, I also, I profiled this down to make it thinner. And with the, I got the top spike here. The top spike basically holds everything in place. So it comes down, it basically saddles on top of the head here, and it rivets down to the shaft, and that's what locks everything in place. So the goal here, what was the goal? There's actually a goal with this project that I started, right? Starting with this poleaxe and then going to this poleaxe over here. So I wanted to kind of find out, okay, if the poleaxes that we fight with, right, these polearms, are they historical? Like, because these things are, like those weigh somewhere in the area of, 4.5 pounds, and over the years, people have made arguments that, hey, a historical poleaxe would never be that light. So a lot of the techniques that we use, where we're going like, we're holding it from the end here and cutting over to that side, cutting over to this side, that these are not historical techniques. It's not something that you can do with a real poleaxe. And that's what I kind of set out to find out, to learn. Okay, I wanted to know, can I build a historical poleaxe with materials that were available at the time using those techniques, and basically be able to, attack from one side to the other side and recover, right? Is it light enough that I can actually move this the way I actually fight? And the answer is yes, you can do it. It's more expensive, it's a lot more time consuming, but it is possible to actually build a poleaxe that does what I do with this, right? So, because here's the thing, if we can't do it, right? If I'm using this to fight a technique that's not real, it's like, okay, well, what am I doing? Okay, what am I practicing? Is this medieval fighting, or is it not medieval fighting? So that's the thing I set out to answer with this project. So that said, it's interesting I did do some hitting tests, right? I've been doing a whole bunch of hitting tests. I've got these barrels lined up over here. So I'm going to hit this here, and these barrels are kind of touching each other, so the force should transfer over to this one, and we can kind of see if that pot moves or how much it moves. So what's happening with this, because of the rattan, this is flexing a lot, and as I'm hitting this, this is, you know, bending back. Okay, so now by comparison, okay, let's use this guy here. Okay, you can see that this one here is moving a whole lot more because there's no give on this. Okay, so it's transferring more of the force into the, you know, more of the force is being transferred into the, you know, through the barrels all the way up into that pot. Now it gets really interesting when I hit with the langets, right? Because this is the most solid part, really, of this poleaxe. Look how much it moves now. Okay, there's a lot more force going in. Okay, so that's going to hit a lot harder. This part here is hitting a whole lot harder than that, just because there's just more mass on this. So that's interesting how this design is working out. Okay, so these are the things I wanted to figure out. You know, the style that we use, like me, for example, taking this axe here and putting tape on the sides here and hitting, because most of the time when I'm fighting, I'm hitting people with this side. I pretty much use this to go past, to extend past things, like to go past somebody's block or past a shield. So I just use this to go past things. Most of the time I'm hitting with this part, and as we can see right here, this is the harder hitting part. Okay, so that's interesting. So yeah, a fun experiment. Like I said, both of these, this has been a fun, interesting project. You know, and as you can see, this one came out a lot cleaner with less. There's a lot less tooling marks on this because, you know, basically this spent a lot. I did a lot less hammering, and this spent a lot less time in the fire compared to this one, because I kind of knew exactly where I was going, exactly what I wanted to do with this. So anyway, let me know what you guys think. Drop some comments, and I will talk to you all soon. Oh, and the top spike on this thing is very serviceable. I didn't put a pointy tip on this because I want to be able to stuff like that. And then you got the end cap. Okay. Now, I did not put a spike here, right? I put an end cap, which is basically like a mace. And the reason is, with this, you know, if I have a sharp pointy spike here, there's a good chance I'm going to gut myself, right? I come down and hit myself. So with this, if this, you know, if this gets pushed into me, this is not going to hurt me. But if I take this and I hit, you know, and actually hit with it, it moves the barrels, as you guys can see. Let's do it from this side over here. You see how it's moving those barrels, and then moving the pot that's on top of that. So yeah, I think that this design here, this poleaxe, which is based on the Wallace collection number A925, I think it's the queen of poleaxes. Okay, now I did, you know, make some modifications from the original one, but I think, like, even Arms and Armor, who sells a recreation, they also made some modification. And the original ones, there's some, like, for example, the head does not, from what I heard, the head on the original is not perfectly centered, right? So even the blacksmith that made the original one that's in the museum, you know, there's some imperfections on that, and they said it was like off center or something. People have said, who have examined it. I want to add one more thing. Why did I use this style of an axe and not the same style that's found on the original, which is like a crescent shape, right? It curves. So there's two reasons. Basically, I'm designing this for singles combat, right? I explained that I'm trying to essentially recreate the metal version of what I actually fight with. And if you have a big crescent shape here, right, this is really good because it gives you reach, right? Because you can reach past shields and past the block of another polearm. And it's really good for pushing, right? Because I can can grab it here and I can push, or I can grab here and I can hook, but it doesn't lock. All right, because if this is a crescent shape, and I know because I've actually made crescent style pole arms, you know, for tournament fighting, and the problem with something that hooks too much is once you get in here, if you got a crescent shape, well, now the two weapons are kind of locked into each other, and it's really hard to get out unless the other person, you know, you end up basically in a tug of war, right? If you know the two weapons are locked, unless the guy you're fighting is going to let you go, it's really hard to get out of that. Okay, so with this, I mean, you can hook, but then you can just turn it to get out. So that's why I prefer this style of an axe head, that way where you can still hook, but you can still, you know, rotate it to slip out. Same thing, you can push, but then you can kind of turn it and get out of it. Okay, if you want to lock, you can lock it a little bit like this. So you can lock it like that. That kind of gives you a secondary lock to do something else, but it doesn't lock you to the point where like you're kind of stuck in a tug of war type of scenario. So the question becomes like, why would you want a crescent? Where would that be useful? Well, I imagine in a melee or in a battle type of situation, if you have some pole arms, right, or you know, or some pole weapons that do have that crescent, and they are able to, you know, lock other weapons. Well, now, you know, the person next to them, their buddy, can basically do the spearing. So in a line formation or in a melee, it makes sense that you might want some pole arms with a crescent shape for the purpose of actually locking other people's weapons momentarily, so somebody else can do the killing. But if you're doing one-on-one combat, yeah, you gotta do the killing yourself. So the locking something up doesn't seem to make a whole lot of sense. That's why I didn't do the crescent shape. The other thing is that if I went with the crescent shape, it takes away from the top spike in a sense, because if you got a crescent that basically curves like this, well, let's say the crescent stops here. Well, now I only got like what, 3 or 4 inches of you know, of top spike, right? So wherever the crescent stops is where the usefulness of my top spike begins. Okay, on the original, what they did is it has a crescent, but the top spike is a lot longer. Okay, so for what I wanted to do, I wanted to go as light as possible. I wanted to go as efficient as possible. So it made more sense to use this style of an axe and to shorten up the top spike a little bit. Okay, so yeah, that's why I went with this style of an axe head versus the crescent one. Hey, just for the hell of it, I thought we'd use the axe head over here, the axe side, and do a little wood chopping. So one of the things I found is that, yeah, the axe head can go into the wood and kind of stick in it. The way I designed this axe head, this primarily hits with the corners. All right, it actually has a slight curve in it like this. It hits with the corners, and this is the side that I would use to hit mail armor with, because these corners are going to bite into that mail. For plate, I would definitely use the hammer side. That's how I would use this. All right, so mail axe side for mail, hammer side for plate. So yeah, this is definitely not designed for cutting wood, but it is a fun thing to do and just to test it out. That one piece that exists in the museum, I mean, there's no other piece like it. There's only one because of all the time and effort. I mean, if I was going to equip an army, yeah, I probably would have just, I mean, I would put this piece here, right? The heavy langets up here, and then down here, if I had wood available to me, especially cheap wood, I would just leave this wood down here. I would go with thicker wood rather than try to reinforce it with the steel. Okay, so drop some comments, let me know what you guys think, and I will talk to you soon.